Hey guys, it's Miss Richardson here. I am working half a day today, so instead of meeting live, this is your recording for Monday. As soon as you're done watching the whole video, send me a message so I can make sure I mark you guys as present for class on Monday, even though we're not meeting live at 8:30. All right, so today we're going to talk about expressions and equations. So if you'll notice on this first screen, an expression is made up of numbers and variables, operations. Here we have multiplication 4 times x, and we also have addition. When you add an equal sign after the expression, the expression turns into an equation. So expressions do not have equal signs, and equations do. Here are our standards and our learning targets for the day. All right, so like I said, expressions are numbers, symbols, and operations grouped together to show the value of something. All right, so on the left, this is our expression, 4x minus 7. And on the right, since we have an equal sign, the whole thing all together is an equation. So these are words that you need to know. So this whole expression right here, 4x plus 9, is the full expression. Now, 4x, that means 4 times x is one term. Positive 9 is the second term. Okay, so terms are separated by plus and minus signs. So this tells us that we have two terms. 4x is a term and positive 9 is a term. So where you have the variable x, x can be any letter from A to Z, and it represents an unknown value in math. So x is being multiplied by 4. So 4 is that big number in front is called the coefficient. So a coefficient is a number by which a variable is multiplied. And then if you have a number without a variable, that is called a constant. So it could be a whole number, it could be a decimal, it could be a fraction. As long as it's not being multiplied by a variable, it's called a constant. So these are all examples of terms. You can have just a number by itself, which is a constant. That's one term. You could have a variable by itself. That's also one term. This whole thing right here, since there's no plus or minus signs in there anywhere, this whole thing, 3xy squared, makes up one term. And then down here, we have an expression made up of 3 terms. We have positive 5a squared. We have positive 2xy. And we have positive 3. So 3 terms on the last example. Now, some terms are called like terms, and these are examples of unlike terms. So to be a like term, the variable and any exponents must be exactly the same. So here we have the exponent of 2, a variable of x. So x squared and x squared. Since our x squares are the same, it doesn't matter that the coefficients are the same, but these 5x squared and negative 9x squared are like terms. Here our variables are ABC, ABC. That means that these two are like terms. Here we have the same y squared and y squared. So 7y squared and 1/2 y squared are like terms. And over here we see non-examples. So 8 is not like 8y because this one doesn't have the variable. 14y squared and 7x squared are not like terms because the variables are different. And both of these have x and y's, but x here has this variable 2 and this one does not. So these are not like terms. So whenever you have a number that's multiplied by a variable, that number is the coefficient. So 1/2 is our coefficient of 1/2 x squared. 16xyz, the leading coefficient is 16. 9 is our coefficient here. And even though this x, the variable x, looks like it doesn't have a coefficient, it actually does. The number is 1 because 1 times x is equal to x. So anytime you have a variable by itself, or even an xyz together, the coefficient is always a 1. So how many terms do you see here? We have 3x squared as a term, positive 5x is a term, and negative 2 is a term. So that sign belongs to whatever that number is right behind it. What are the coefficients? The coefficients are numbers multiplied by variables. So our coefficients are 3 and 5. And is there a constant? Yes, there is. It's a number not attached to a variable. So the constant is negative 2. That minus sign belongs to the 2. All right, there's our 3 terms. Our coefficients are 5 and 3. And our constant by itself is negative 2. All right, so here it says to list how many terms are in each expression and also list the coefficients. So I want you guys to pause the video and see if you guys can figure out all these answers by yourself, and then turn your video back on and see if I agree with you. All right, so the first one, how many terms do we have? We have 3 terms. And what are the coefficients? The coefficients are 2 and 3. 7 is a constant, it's not a coefficient. Number 2, how many separate terms are there? There's 3 separate terms. What are the coefficients? We have 6, 12, and 3. The next one, we have 1, 2, 3, 4 terms, and those coefficients are 2 and 10. 4 and negative 2 are constants. Number 4, how many terms? We have 2 terms, and what are the coefficients? Did you remember the 1? 1 and 8 are our coefficients. And number 5, we have 1, 2, 3, 4, 5, 6 coefficients. No, we don't, sorry. 6 terms. And what are the coefficients? They're 2, 4, 12, and 8. How'd you guys do? Did you get them all? All right, moving on. Now, I do want you to come back and watch this Math Antics. Oh, it's not a Math Antics video, but I do want you to come back on the slide deck and watch this video after you're done watching mine. A lot of times I say come back and watch it if you need to, but since we're not having class today, I want you to see as many examples of writing expressions as word phrases. So I do want you guys to come back and watch this video. Do what Ms. Richardson says, please. All right, so we've seen these lists before of all the words that represents addition, all the words that represent subtraction, multiplication, and division. The biggest ones used are more than, sum for subtraction, less than, difference, multiplication, product, and of course, quotient describes division. All right, so let's see if we can write an algebraic expression that is described in these words. All right, so we've talked about more than and less than before. These two are reverse order. Almost everything else, however it's written in words, that whichever number comes first in the word phrase, that number must come first in the algebraic expression. The difference is more than and less than, okay? So when you have 3 more than something, that 3 actually goes to the back. So T plus 3 is the right answer. Now, of course, we learned about the commutative property of addition. So if we wrote 3 plus T, technically that is still correct. But with subtraction, the order is very, very important because there's no such thing as commutative property of subtraction. So be careful with less than. All right, a number y, our unknown number y, decreased by 4. The product of 3 and a number, so 3 times any variable, and the quotient of 25 and a number, the 25 must come on top, is written first, or you could write it this way, and you could use any variable you want, of course. All righty. Hey, we got them right. We got them right, you guys. All right, so I want you guys to try that. I want you to write an algebraic expression for each of these. I want you to pause my video, try it on your own, and then come back and see if we agree with each other. All right, M increased by 5. So M increased by 5. 8 less than. That's that tricky one, guys. It must come last. A number minus 8. If you wrote 8 minus x, that is not correct. You would miss that on a quiz or a test. Okay, guys? A number r divided by 15, or you could write it this way, of course, but the r must come first. 27 times what? The sum of x and t. So let's go ahead and write the sum of x and t. And then it says 27 times all of that. Okay? So that looks like a distributive property. Here's another less than, very important that 11 comes at the end. So it's something minus 11. So what are we going to start with? 4 times a number y. So 4 times y, and then 11 less than that. That's the answer. And 2 more than, so we're going to stick this at the end, more than 6 times a number. How does 6 times a number look? 6 times a number, and then 2 more than that. There we go. Did you get them right? I hope so. All right, so let's do the opposite now. We're going to be given an algebraic expression, and you need to come up with word phrases. So there's a lot of different answers to these. So this one of your answers could be 2 increased by a number. You could say 2 plus a number. You could say the sum of 2 and x. You could say x more than 2, x more than 2. You could say 2 increased by x, a lot of different choices for those. So I want you guys to give it a try. You can pause the video and say verbal phrases, write them down, and then start the video back and see if I agree with you. All right, so on the first one, we could say 3 times a number. We could say the product of 3 and x. We could say 3 times x, 3 multiplied by a number. Did I say the product of 3 and a number? I don't remember. All right, what about number 2? You could say a more than 8. You could say the sum of 8 and a number. You could say 8 plus a. 8 increased by a. Number 3, you could say 9 more than 2 times a number. 9 more than twice a number. You could say the sum of twice a number and 9, right? Any of those? And then here we could say y less than 2. We could say 2 minus y. We could say the difference of 2 and a number. Those are pretty good. What do you think? All right, do you have it? Do you have it? All right, so we started talking about like terms earlier. So these are all like terms over here. 7x, x. Uh-oh, I didn't mean to do that. 7x, x, and negative 2x are all like terms because they all have the variable of x raised to the first power. So anytime we don't see a variable, not a variable, but an exponent, it's automatically 1, just like the number 8 is actually 8 raised to the power of 1. But if the exponent is only 1, you don't have to write it. So technically, these all have the same variable and the same exponent of 1. All right, what about these 3? They're all unlike terms because of the variables and that exponent. This one has y to the first, but this one's y to the second, so they are not like terms. Same thing down here. These are all unlike terms. It doesn't matter that the coefficient of 2 is the same. What makes it a like term are the variables and the exponents. So be careful with those situations, okay? All right, so I do want you to come watch Mr. Math Antics. He's going to start talking to you about like terms, and then there's another video about combining like terms. So just for extra review, I want you guys to watch those. Now, when you say combining, it means a lot of times adding, sometimes subtracting, but you're going to put together like terms. All right, so look at this expression. We have 3x is like positive 7x. So when they have the same variable and exponents, you're going to actually add those coefficients. So 3x plus 7x is 10x. And then our constants are always like terms. So 6 plus 3 is 9. And so when I say simplify this expression, This is as far as we can go, guys. We can't add 10 and 9 because they're unlike terms. So the final answer is 10x plus 9. And we've simplified that expression. We have combined like terms. All right, so let's look at this long expression over here to the right. So what is like 3a? Well, that would be positive 2a. So we have 3 apples, add to 2 apples, and we get 5 apples. All right, what is like 6x? 6x is like positive 5x. So 6 plus 5 is 11. So 6x plus 5x is 11x. And then the positive 4 is by itself, but it still must be part of our answer. So the final answer after combining like terms is 5a plus 11x plus 4. Yep, and they're showing the different ways to symbolize those like terms. So 3a and 2a is 5a, 6x and 5x is 11x, and positive 4 is part of the answer. So the final answer is what we had written already. All right, like I said, Mr. at Math Antics is talking about like terms. Great video. You need to come back and watch this on the slide deck, please. All right, so now we're going to practice. So if you feel brave enough, I want you to pause the video and try these by yourself. Actually, I want all of you to try them by yourself and then watch the video and see if we agree with each other. All right, so when we combine like terms on the first one, we have 2x plus 3x plus 7. So 2x and 3x is 5x, and then plus 7 is part of my answer. Just like that. That's as far as we can go. It is not 12x. That is not right. It's 5x plus 7. All right, over here we have 6 worms plus 12 worms. What's 6 worms plus 12 worms? That'd be 18 worms. And then we have 3 zebras by themselves standing over there looking at the gross worms. All right, what about the next one? Our constants 4. This isn't a positive 2. It's 4 minus 2. What's 4 minus 2? It's 2. And then we have 2 yo-yos plus 10 more yo-yos, which will give us 12 yo-yos. All right, and even if you write these in a different order, if you write 12y plus 2, that is correct. Here, if you wrote 7 plus 5x, that is correct. Same thing here. 3z plus 18w is the same as what I wrote. All right, what about this one? How many apples is this? This is 1 apple plus 8 apples. Altogether, we have 9 apples. 9 apples. All right, the last one, let's start with our a squared. And it doesn't matter if you don't start with a squared, but that's what I'm going to start with. All right, so what is 4a squared plus 12a squared? That would be 16a squared. All right, let's move on to our a's with a power of 1. 2a and 8a. 2a plus 8a is 10a. And then finally, we have our constants. We have positive 3 minus 2. What's positive 3 minus 2? That's positive 1. So 16a squared plus 10a plus 1 is our final answer. I hope you got them all right. All right, so we're going to stop right here for Monday's class, and on Wednesday, we will start on this slide right here. So you should be able to do your assignment that's labeled for tomorrow. I'll see you guys tomorrow for social studies. If you need any help, please let me know, and I will check in with you guys later, and have a great day.